If you take India, India is very much less affected with the help of with friends. But if you take US, for those of you who are flying from US, this chapter is very, very important because this is one chapter or this is one phenomena that will affect a lot of your flying. So you have to be very much careful whenever a cold front is approaching. So you have to expect that your visibility will be very bad when a warm front is approaching. So what is this cold front? What is this warm front, etc.? We will understand today. To understand front, you have to understand something called as air mass. Air mass is nothing but a huge mass of air sitting at a particular place. For example, if you take a large mass of air sitting on this continent like this, sitting on this continent like this. See, this continent is like North America, which is a bit closer to poles, probably Canada and all. Right? It is a very cold place. So this air mass, if it is there for like 15 days, 20 days, 30 days, it will also become cold. Yes or no? So that mass of air covers like around thousands of kilometers of area. Correct. Now take this mass of air. This mass of air is also closer to poles like this mass of air. Correct. So this will also be cool. So both are cold. This is cold. This is cold. Now what is the difference between this mass and this mass? This mass is sitting over land. This mass is sitting over. This air mass is sitting over ocean. Correct. That means this mass will have more humidity. It will be cold and it will have more humidity. Now this mass will have, it will be cold, but it will have less humidity because there is no water vapor supply from below. Correct. Less humidity. Now let's assume a mass of air sitting in the ocean. How will be the humidity? This is the equator. That is, this is the equator. Close to the equator. How will be the humidity in this? See, first of all, the mass will be warm or hot. Now there is water supply and it will hold a lot of water vapor because
Or
it is very hot
humidity.
also. Yeah. Warm and more humidity. Am I clear on this? So these are called as air masses. They constantly form because sometimes air gets stagnant over a large land or something like that. Correct. Now, so where do they form? Majority of them, they form in only high pressure areas. Can someone say why? Majority of air masses form in high pressure areas. Can someone explain me why that is happening? Why only high pressure areas are giving air masses? This is because, see, if you take low pressure area, the isobars are closely spaced and a lot of air movement is there because of pressure gradient force. Correct. But in high pressure, the isobars are widely placed and not much movement of air is there. Only less movement of air. So if a mass has to acquire properties of the land or sea that is below it, it has to stay or spend some time at that portion. That is the reason high pressure areas are the places where majority of these air masses fall. Now, see, air masses are Air masses are divided based on number one, temperature. Number two, based on humidity. Correct? These are the only two factors, whether the air mass is hot or whether it is cold, whether it is humid or less humid. If the air mass is forming close to the equator, close to the equator in the sense in the tropical areas, so it is called as tropical air mass. How will be the temperature? Temperature will be very high. If the air mass is forming close to poles, it is called as polar air mass. How will be the temperature? Temperature will be less. If the air mass is forming over a continent, that means it is forming over a land, correct? So humidity will be less. That kind of air mass is called as continental air mass. So less humidity. If the air mass is forming over sea or ocean, it is called as maritime air mass. Humidity will be more. So any air mass or all the air masses are divided as follows. So tropical air mass, is this air mass forming close to land or sorry, close to equator or in the tropical area or in the polar area? In the tropical area. So it will be, the temperature will be high. Correct. And it forms in the, it is also forming over the ocean. Correct. So example is this.
Humidity high.
Yeah, maritime plus tropical. Tropical maritime air mass. So humidity will be very high. See, why is it very high? Because if you increase the temperature, because it is forming closer to the poles, here the amount of water vapor carrying capacity also increases. We have seen in previous chapters, correct? So relative humidity is very high. Next, tropical. That means it is forming close to equator and continental. So tropical, so it is temperature will be high, and continental because the land gets very hot easily, na? So it becomes very high. Temperature will become very high, and relative humidity will be very low. Am I clear? Am I clear on this? Am I clear on the same way? Polar means temperature will be low. Continental means temperature, sorry, humidity will be low because it is forming over land. Polar maritime, low temperature and more humidity. There is one air mass which forms very close to the poles, Arctic. It will be very cold also. Now, when it forms very close to the poles, now what is the humidity close at the North Pole and South Pole? From the first chapter.
Sir, area is cold, that means humidity low.
See, yes. See, closer to the poles, what happens is the air mass is so cold that it cannot hold any water vapor. That is the reason I have taught you in first class. Close to poles and beyond 20,000 feet, water vapor content is almost negligible. Correct. So that is the reason Arctic air mass has very low relative humidity. It can form on ocean, but it will have very low relative humidity. Star. Is this under classification of air masses? Okay. So note down. temperature decrease, the capacity of air to hold water vapor decrease. That's why Arctic air mass, even though it's forming on oceans, it doesn't matter. The relative humidity will be low. Beyond 20,000 feet and at poles, humidity is almost zero. It's not relative humidity. Take it as humidity. Shall I move on? Any doubt till now?
So just a minute, I'm on the last row.
Okay. Don't copy down. See, write down and cross check your answers. That's all.
Sir, can you please scroll up once?
Shall I move on? These are some of the examples. See, it is close to the poles. Polar continental air mass. This is close to the equator. So tropical continental because it is over land. So this is close to the equator. So tropical and it is on
Maritime.
ocean. So it is tropical maritime. So this is how you name. Is it difficult? No. So what are fronts? See, let's take an air mass which is cold. Let's take an air mass which is warm. Tell me which air mass will have more density?
Sir, cold.
Cold. Cold air mass will have more density. Warm air mass will have less
Less density.
density. Okay. Now, for some reason, you brought these two things together like this. This is the cold air mass, and it is getting mixed with the warm air mass. Now, what happens to the air which is getting mixed? See, cold mass, air mass has more density, and warm air mass has less density, correct? Here, this is like thousands of kilometers. Here, it is not a very simple thing. So, this mixing happens for, let's say, 500 kilometers. Now, what happens when you take a balloon and put helium gas in it and leave?
It rises.
It rises up. The balloon will go up, keep on going up. Why it goes up?
Because
Because,
it's very light, lighter than what we do from our.
yes. So, surrounding air has higher density when compared to helium because this helium is filling this balloon. It will be lighter because of less density. It is pushed up. Correct? Now, when you mix cold air mass, which has more density with warm air mass, what happens? The air from the warmer side, because it is lighter, it will rise up. So warm air mass will be having water vapor also. Correct. So when it rises, what happens?
Formation of cloud.
Clouds, and it will give rain. Correct. So the place where air masses of two different properties, two different temperatures, two different humidities meet, there obviously there will be rain. Why? Because one air mass will be colder than the other. Assume both, one is at 45 degrees, one is at 60 degrees, very hot, but what 60 degrees air though will rise, obviously. Correct. So if there is a temperature difference, there is going to be rain, there is going to be formation of clouds. So this place where they meet is called a front. Like sorry, if you see two kingdoms fighting, correct, so people will be like, in the good olden days they were fighting on the ground, correct, so people will be coming to fight each other, so these guys will come forward, they meet here. So this part where they hit each other is called as battlefront. Correct. So front is a place where two air masses of different characteristics meet. How many of you are comfortable with the definition? Correct.
Got it, sir.
Front is the part where two air masses of different densities meet. Stomach. Correct. Now, see, this is a very rare phenomena. Okay. Generally, the scenario will not be like this. The scenario will be like this. Let's say this is a cold air mass. This is a warm air mass. Right. The cold air mass will be moving forward with some velocity. Then it will come and meet the warm air mass. You understood? So this is how the air masses meet. Am I clear on this? Am I clear on this? So, now, let's say it is blowing with the wind, it is going with 30 knots. Now, what happens to the warm air mass? See, which is heavy, which is more dense?
Sir, cold air. Warm air goes up.
Correct. The cold air is more dense, or it is more heavy. This is like a car, and warm air is light. This is less dense. This is like a bicycle. Do you see? If the car hits the bicycle guy will not fall down. He will rise up in the air. Because you understood? What happens? The cold air mass undercuts the warm air mass, lifting the warm air mass up. This is the cold air mass. Warm air mass will rise up over the cold air mass. So the cold air mass will progress like this. You understood? Correct. So write down here. When cold air mass overtakes the warm air mass, This is called a cold front. That means the cold air mass is coming and hitting the warm air mass. Is this line clear? The cold air mass overtakes the warm air mass. This is called a cold front. At a cold front, the cold air undercuts the warm air, and the warm air rises above. Am I clear? Is this understood? Now, do you see the cold air mass is undercutting the warm air mass like this? Okay, so it will spread like this, and the warm air will rise above the cold air. When it is rising, it will form clouds. Correct. Now, because the cold air mass is very heavy, when it hits the warm air mass, it will rise violently up very fast. The movement of rising of the air is very fast. So this will lead to the formation of CV clouds. So at the cold front, the most commonly formed clouds are CV clouds. Sorry for that. So when the air is violently rising up, correct, because cold air is very heavy, it leads to formation of CV clouds. This is the most common cloud that is formed at cold front. Now let's see what happens at the warm front. That means here cold air आराम से जा रहा था, और it was moving very slowly. अब क्या हुआ? This is the warm air. Warm air goes and hits the cold air. For example, a bicycle hits the car. What happens to the bicycle?
It falls.
Falls. Or see, if a car hits the bicycle guy will be thrown, because car comes at a very high speed and it has very heavy power. Correct. But if a bicycle guy comes and hits the car, bicycle guy will tumble over the car. Understand? If you see this, here, see the bicycle guy, if the car is heavy and he goes up, he is thrown up into air like this. Correct. But see, if a scooter or bicycle guy comes and hits the car which is not moving or stable, what happens? He will tumble over. That's all. He will not get super high. He will just tumble over, or he will smoothly do this and he will fall down. Correct. The same way, the warm air cannot undercut the, see, the bicycle guy cannot lift the car and throw it up. Correct. And car is not hitting the warm air. What happens? The warm air slowly rises above the cold air like this. You understood? Now compare these two things. Where is the slope very high? Warm air, sorry, cold front or warm front?
Cold front.
Very good.
So high or steep?
Slope high means, like, see, this is slope, correct? So this is steep, correct? That means slope is high. Steep means high, correct? Shallow, slope is shallow means slope is low. So where is the low slope? Warm air, correct? Understood. So when the steep is slow, warm air is doing this. This is the cold air. The warm air is rising above it. Correct? This is the cold air. And the warm air is rising. How many of you understood? So this is called as warm front. Warm front means warm air mass at a higher speed hits the cold air mass, and what happens? What happens? It rises over the warm air mass at a shallow slope. Correct? And it rises over the, sorry, over the cold air mass at a shallow slope. Till here it is clear. Any doubts?
Yes, sir.
No doubts. Okay. Now see, let us compare the two air masses. Okay. So which one do you want to learn first? Warm or cold?
So cold.
Cold. Here, see, which is more speed? Is it the car or the bike? Always the car attains more speed. Correct? Because when there is a difference between two areas, the pressure difference, if the air starts moving like this, the momentum is gained and it is kept if the air mass is cold. If it is warm air mass, so this air which is here will try to stop it and it will get stopped. Understood? So cold front is double the speed of a warm front generally. The cold air masses move with more speed. than the warm air masses. Am I clear? So cold front is of double the speed than warm front. First point clear. Now see, slope is high or low?
Sir, high.
Slope is high. Slope is steep, or for every 50 feet, there is rise in 1 feet. Correct. Slope is steep or high. If you take cold front, you see the slope is not very much high. You understand? So for every 120 feet only, there is a height rise of 1 feet. Correct. So 1:150 or 120 is less slope, or this is called shallow. This is for warm front. Now for cold front, it is 1:50. Correct. For 50 feet, there is rise in 1 feet high of the warm air. So slope is more, or called as steep slope. Are the 2 points clear? Now, see, as I described, what happens when you mix cold air with warm air? So cold air is actively pushing the warm air up, and when there is a mixing, the warm air is also rising up because of the cold air. Correct? Understand? So warm air, or at the cold front, the warm air always rises very fast. So can I say if the air is rising very fast, it is unstable? Right? That will lead to formation of clouds and precipitation.
Yes, sir.
So cold front is always unstable. So when there is unstableness, correct? When
CB
there
will
is
form.
humidity, yeah, CBs will form. Correct. So the front is always unstable. Correct. So when the front is always unstable and the air is going up with less slope, cumulus clouds will form, which will turn into CB clouds. So more clouds which are vertically develops. Correct. Cumulus and CB clouds, they develop vertically up. So more vertical development of clouds. Are the first 4 points clear? Now take a look. See, is the air going violently very up? No.
Awesome.
So it will slowly form clouds like this. Can someone say what kind of clouds are these, which are more horizontally developing?
Stratus.
Correct. So at a warm front, you find stratus clouds. At a cold front, what do you find?
CB clouds.
Define fog.
Cloud on ground.
Which cloud on ground?
Status.
Status cloud.
Fog is nothing but stratus cloud lying on ground. That's why you just go a little bit up, you can see the clear skies. But inside the cloud, this thing is stratus cloud on the ground. Now, at a warm front, the slope is less. This is cold air, and this is warm air. Correct. Now, it is all forming stratus kind of clouds. Can I say if you're flying and a warm front is approaching, see, whenever a warm front approaches, it is represented by blobs like this on a map or a chart. You understand? So if you see this, what do you expect the visibility to be?
Less.
Visibility will be less. Why? Because a lot of stratus clouds are forming. That means a lot of fog is forming. Correct. So visibility at the rate of warm front, visibility is less. Or fog forms at warm front. Am I clear? See, I'll show you the actual pictures. Okay. So which front is this? Which front is this?
Cold front.
Cold front. Why cold front? See,
CB.
the cold air is moving and hitting the warm air, and the warm air is rising. So when the warm air is rising at a very high slope, correct? So it is rising up and it is forming CB clouds. Correct. So CB clouds. So this is a cold front. How many of you agree? Understand?
Yes, sir.
Correct. Now, how is the visibility in CB when at the cold front? Question they asked. At cold front, how is visibility? Is it more or is it clear or visibility is good or bad?
Sir, visibility bad.
No. See, I have already taught you once this. Whenever a rain is happening, correct, you cannot say visibility is bad. You understand? See, whenever there is fog, visibility is less. But in rain, visibility is bad only during it rains, or only in precipitation the visibility is bad. But as soon as it stops, the visibility is going to get improved. Correct? So, but at the warm front, what happens? There is fog. So if it is raining or not raining, it does not matter. You understand? Visibility is bad at the warm front. But if you take at the rate of cold front, yeah, these every line is a question. That's why I'm writing again and again. At the rate of cold front, visibility is bad only in precipitation. Visibility is bad only in precipitation. Am I clear? So shall I move on to next thing?
Yes, sir.
These were the slides from previous classes. Please don't mind. The thing is like I have to clear a lot of memory in this. Until then, new slides are not getting loaded up. Okay. The first point was clear. Double the speed, slope is steep, front is always unstable. This is the cold front, right? More vertical development. Next. Can I say at the cold front, what kind of clouds develop? Clouds with large vertical development or CB clouds. Sometimes as the front approaches, there will be a line of CB clouds. This because this air is rising up even before the front is approaching, correct? So this kind of line of CB clouds probably for around 100 kilometers or so, this is called as line squall. Am I clear? No. See, I have already explained in the chapter thunderstorms why winds will be squally at the thunderstorm. Correct? Why? Whenever there is a CB cloud forming, the CB cloud has updrafts and downdrafts. The downdrafts are due to water droplets and hail falling down. Updrafts are due to the low pressure area being created below the CB due to a trigger. Now, when this happens, the air will rotate. So it will exit the CB cloud like this. So if you are standing here, sometimes you feel the air coming from here, sometimes you feel the air coming from here, sometimes you feel the air coming from here. So there is sudden change in wind direction and speed. So this is called as a squall. Correct. So wherever there are CB clouds, squalls will happen. Can someone say what is other characteristic of CB clouds? What is the other word which you, if you hear it is CB cloud?
Shower.
Very good. So it will give showers. Correct. So here you write down only in precipitation in brackets showers. If they are saying showers in the question, they are obviously talking about CB cloud. CB cloud is going to form only at cold front. Am I clear on this? Next. So as the front approaches, winds suddenly become squally because CB clouds are there. There will be violent thunderstorms, hail, and CB clouds. Is this clear? Line squall. That means line of CB clouds 100 to 300 kilometers ahead of the front. Correct. So ahead of the front, the precipitation is due to CB clouds. Till here it is clear. Every point.
Yes, sir.
Okay, next. So behind the front, see, whenever the front passes, that means this front moves here. See, and one more thing, cold front is represented by triangles like this. You see the triangles? Correct. So for example, if there is a map, okay, so let's say this is North America, this is South America, correct? This is like Europe or something like that. So if they have represented on a weather chart today like this, it means which front is approaching?
Cold front. Cold front.
This is the cold front. That means, see, this is the cold air, this is the warm air, and they are now today meeting at this point. This is warm air. Understood? That is how you have to think in your brains. Am I clear? So ahead the precipitation is due to CB clouds. But now when they pass, see these CB clouds become slowly dissolved into the cirrus clouds, stratus clouds, correct? Yeah, I have also taught you how they dissolve. Okay. Do you see? These clouds will slowly dissipate like the cirrus clouds and they come down. So probably some stratus cloud, correct? Now behind the front, if it is raining, it will rain due to the nimbostratus or altostratus clouds. So they will particularly ask at the front, the rain is due to CB. Ahead of the front, the rain is due to CB. But if they ask behind the cold front, the rain is due to nimbostratus. Am I clear? So behind the front, precipitation is due to nimbostratus and altostratus. Till now, every line is clear. You understood?
Yes, sir.
Okay, now see, stratus cloud is forming at the start of the cold front or behind the cold front? Behind. Correct. Nimbostratus
Yes, sir.
and altostratus clouds are forming behind the cold front. Correct. So that is the reason you say here when a warm front is approaching, fog forms at the front. But fog forms after the cold front passes or at the end of the cold front, the fog will form. How many of you understood the difference?
So can you
So
repeat?
please tell again.
See, so this is warm air, this is cold air. So warm air is coming with very high velocity and hitting the cold air. So it cannot lift the cold air up. So itself, it goes up like this because the slope is very less here. Correct. So the clouds will form like this. See this clouds. Correct. So this is cirrus clouds. This is cirrostratus, altostratus, stratus, nimbostratus, and here it will be stratus or fog. So can I say at the warm front? That means at the warm front in this place where the warm air is hitting the cold air, there is fog formation. So at warm front, fog will form. Is this clear? At the warm front, fog will form. But see, will the fog form at the cold front? No. What happens here at the cold front? CB clouds will form. Correct. It will give a lot of rain, lot of precipitation, lot of thunderstorms, very bad weather. But see, once the cold front keeps on, see, the cold air keeps on moving up, moving forward. Correct. So the front, it was like this on the map. Correct. After some time, after 3-4 days, you see it has moved ahead. Correct. But this area, let's say this is North America, which was experiencing lot of CB clouds 2 days back. Now what happens? These clouds, CB clouds, will dissipate and form nimbostratus and altostratus clouds. Correct. So after the passage of cold front, this will experience fog, nimbostratus or altostratus clouds. Correct. Stratus clouds means fog, visibility is bad, and of course nimbostratus and altostratus are also stratus clouds. They will give rain. So nimbostratus and altostratus, here they give rain primarily at the cold front, but at the warm front. At the warm front, the rain is due to nimbostratus and altostratus. But at the cold front, the rain primarily is due to CB clouds. But after the passing of cold front forward, correct? After the passing of cold front, now the nimbostratus and altostratus form at the end. So visibility becomes bad at the end. So if they ask after the passage of cold front, the rain is due to nimbostratus and altostratus. Correct. So during cold front, visibility is good, but fog forms after the cold front, visibility is bad. How many of you understood? Arshita. So is this line understood? Ahead, precipitation is due to CB. Behind the cold front, precipitation is due to CB and NS. Fog forms at the end of cold front. Correct. Now, ahead of the CB, ahead of the cold front, CB clouds are forming. Behind the cold front, nimbostratus and altostratus clouds are forming. So precipitation occurs 30 to 50 kilometers on both sides of the front. Around like 100 kilometers, totally it will be completely raining at the cold front. So whenever a cold front is approaching and you're flying, be very careful. You're going to expect a lot of CB clouding. Am I clear? No. Let's see warm front in detail. How is the slope? It is shallow. Correct. This is understood. More horizontal development of clouds. That means stratus clouds. Now, this point is applicable only to northern hemisphere. What happens to wind in northern hemisphere? If the wind is moving in northern hemisphere, what happens to it due to
Move
Coriolis
to the
force?
right.
Correct. So wind is deviated to the right due to Coriolis force. Correct. Now, at the warm front in northern hemisphere, when the wind moves, see, initially let's say it is moving 070. After some time, if you see, what will be the wind direction? 100. That means it will move, or it will, what is it called as when the wind changes in clockwise direction? From the wind step.
Veering. Ha.
Correct. So wind will veer. Wind will veer in warm front. Here, in cold front also wind should veer. Why is it not veering? Any idea? Anyone can explain? See, in the cold front, what happens? Winds are squally. That means they change the direction constantly. Correct? They keep on coming at random directions because of this. I've explained. Correct? We need the thunderstorms. The winds will be squally. Correct? The roll clouds will come out underneath. So in a cold front, it does not happen. But in a warm front, you can expect their winds now, they were coming from, let's say this is 250. After some time, they come from 280 like this, something like that. Okay. So this was the wind directions. Okay. So wind will veer and strengthen because it with time the wind speed increases. Correct. Wind will veer and strengthen, strengthen at the rate of warm front. But if you talk regarding winds, at cold fronts, winds are squally. The rate of cold fronts. How many of you completely understood the difference between these two lines?
So why did you take Northern Hemisphere before explaining? You said that.
Wait, in the southern hemisphere, close to the South Pole, there are not many continents. Correct. So that is why we generalize this term and say here at the warm front, wind will veer and strengthen. And that statement is correct, even if they don't mention northern hemisphere. But if you take southern hemisphere, see, it will strengthen, but it will back. That means it will change opposite because the in southern hemisphere, Collier source turns to the left, not to the right. But nobody will ask you, don't bother to remember also. Don't write down, you will get confused. Okay, just understand the concept and keep it in your brain. So wind will veer and strengthen at the warm front. So at the cold front, winds are square. Shall I move on forward? Shall I move forward? The winds will strengthen and veer as the warm front approaches. Now see, in a warm front, cirrus will form at very high levels. Cirrostratus, altostratus, nimbostratus, and stratus will form. All clouds are stratus clouds. And they form in the sequence. Why? Do you see? When the air rises, first you will see the cirrus clouds above you. So if a guy is standing here, he will see the cirrus clouds. Next, if the second guy is standing here, he will see cirrostratus. He will see altostratus at medium levels. Then he will see nimbostratus and stratus. And this guy will experience fog. If you're flying here also, he will experience fog. Understood? Am I making sense? So they form in sequence: cirrus, cirrostratus, altostratus. Nobody will ask you, but you just have to have an idea about these things. Am I clear on this? Am I clear? Shall I move forward?
Yes, sir.
This point is understood. Now, fog occurs at the front in the warm front. That's why warm front is called as, the fog in the warm front is called as frontal fog. So at the front, the fog occurs. But where does fog occur in the cold front? Answer, please.
Behind.
Behind.
Behind the cold front. Very good. Very good. So the fog at the warm front is called as frontal fog because it occurs at the front. Correct. So when you take cold front, fog occurs behind the cold front. Am I clear on this?
What is that called then? The one that forms the behind?
There is nobody gave any name here. Let us name Sanisha's spot. What is that thing here? This advertisement comes, na? Fog. What is the tagline?
क्या चल रहा है? Fog
Huh?
चल-
Huh?
It's called. They're like two people having a conversation, and the other one will approach and say, "और भाई क्या चल रहा है?" And he'll say, "Fog चल रहा है."
That means no gas or no time pass. Okay. Tanisha, no time pass. Understood? Okay. इधर fog चल रहा है. Frontal fog चल रहा है. That too. Clear? Okay, good. See, visibility is poor ahead and during the warm front. Why? Because ahead and during the warm front, fog is forming. But visibility is good except in the showers at cold front, and behind the cold front, visibility is bad. Ahead of warm front, winds will strengthen and wear. In brackets, if you want to write down northern hemisphere, and you know the concepts also. Correct. So this is it for today. Okay. So there are two other different types of fronts. One is occluded front, one is stationary front. Okay, very easy and simple. Okay, and there is one more topic called western disturbances. Here, this western disturbances, na? If you are living in North India, okay, so whenever you think of these western disturbances, do this. Because of this only, these winds only, you are eating your roti, jawar. You understand? So we will see how these western disturbances are helping India. Okay, if not, you will not have your roti. Like our South India people, Sanisha, you also will be eating rice only. No rotis for you. Am I clear? So shall I call it a day? So if any single line you don't understand, you ask me now. So revise this, whatever you wrote down the notes. Tomorrow there is no class. Okay, I have a work. I'm taking off, and probably day after tomorrow, even though it is Sunday, I might take a class. Okay. Bye bye, guys. Take care.
Okay.
Hmm?
So those two questions that I put in group, do you want to add anything to that? Or
Yes.
what we were discussing over there was like,
Yes,
okay.
yes. I want to add. No. That is not okay. So few meteorologists are there in class. They were discussing. Okay. You see, don't see the messages. Okay. That's a personal group. My friends. You see my WhatsApp? No? Okay. Fine. Water vapor is transparent to terrestrial radiation, completely, partially indifferent. So, okay. Let's say this is a cloud. Okay. Now this is the ground. See, let's assume a cloudy night. How is the cloudy night? Is it warmer or colder? Cloudy nights are
Warm only.
Warm.
warm. Huh?
Yes, sir.
Who said cloudy nights are colder?
Nobody.
Warmer.
Warm.
Okay, so everybody is saying warmer.
Yes, sir.
Very good. Why?
Yes.
Because see, land will radiate heat in the night, correct? But that radiation, because water vapor is a which gas? Greenhouse gas, correct? So it will absorb the heat, and what will it do? From once it absorbs the heat, it will also radiate. It will radiate in all directions, correct? It will send in this direction also. That is how heat is trapped. Okay, but what happens? It will also radiate in this direction also. Correct. That means some of the total heat is not trapped. Some heat is escaping these clouds. You understand? Is the diagram very clear? Okay. So water vapor is transparent to terrestrial radiation, but only partially. Or some of the radiation is trapped here. You understand? If you take a mirror, which is behind me, so that mirror is completely reflecting the light. But if I take a piece of cloth or something like that, so I can see what is happening on the other side, but it is not very clear because the cloth is like partially stopping the light passing through it. You understood? Correct. So water vapor is not totally transparent. It is only partially transparent to terrestrial radiation that happens in the night. Am I clear?
Yes, sir.
Let me check what were you discussing. The word transparent means water vapor will pass through. Okay, same examples. Sanisha, what is this here? Genius. Maybe because it is released the condensation. No, see, when you're talking about radiation, Harchita, you cannot bring in condensation here. They have in the question, they were clearly talking about radiation, heat loss due to radiation. Possibly, yes. Thanks. Oh.
So no, doesn't it make sense? The answer is convection and condensation only. Convection is understood. What happens? The warm air going here and there, warming up the
There is
surroundings.
one more question.
No, sir, only these two. But
Yeah, the second question I did not read. Na?
okay. Yeah, there were two, na?
Yeah, I did not see this second question. Several physical processes contribute to atmospheric warming. Which of the following contribute the most?
The condensation makes the air warm, which is near the Earth's surface.
Everybody, okay, go to your first chapter, open your first chapter, write down whatever I have made you write down in the notes. What is latent heat? What is sensible heat? And which is more? That's a homework. Write it 2 times. And then tomorrow, again, ask me the same question. You will not ask me the same question because you will answer this question directly. This is already discussed. I want you guys to take a look at the first chapter once. Okay, 2 times homework. Fine. Can I take a leave? Any more doubts?
So I have a doubt, sir.
Okay.
So I have posted in the group.
Now,
Oh, wait a second.
post it.
Yes.
Okay.